Hello, everybody. Welcome to Calculus 3. This is homework assignments for section 4 of chapter 12. Section number 1. Find the length and direction of the u cross v and v cross u of these two vectors. All right, so in order to find this now, we have to do, since it's a cross product, we have to use the matrices. So we're saying that u is equal to 7i minus 2j minus 8, and v is equal to 8i minus 8k. Be very careful because there's no j's. The quickest mistake students do is when they see this, they think it's I and J, there's no K. So it's easier if you do it this way when you start dealing with cross products. So the first one we're looking at is a U cross V. So we create our matrix. Since U is the first one, we put 7, -2, -8. And V is the second, 8, 0, -8. We're looking for the determinant. I like to use the other method instead of using the sub matrices. I just take the first two columns and repeat them. Now it's just a matter of multiplying these, add up all those, and subtract all those. So we have -2, -8. It's positive 16, so it's 16i. -8 times 8 is -64j. 7 times 0 is 0k. Minus -8 times 7 is -56. It's j. Minus 0i. 8 times 0 is 0. Minus 8 times -2 is -16k. So that becomes a plus. That becomes a plus. Okay, how many i's do we have? 16 minus 0 is 16i. -64, positive 56, so 60, so it's going to be negative. 64 minus 56 is 8j, and positive 16k. So the length of that matrix (16 squared -8 squared 16 squared). But then the calculator, you get 24. So that equals 24. Then, okay, the next part saying, select the correct choice below, and if necessary, fill in the blanks. Okay, so what's the direction? Since we know the magnitude, all we have to do is so 16I minus 8J plus 16K over 24. 16 over 24I, 8 over 24J, eight goes in 16 twice, it 2 over 3, I 1/3, J, and 2/3 K. So that's the direction it's going. So it's 2/3, negative 1/3, 2/3. So 2/3, negative 1/3, 2/3. Now we're going to do V cross U. Now we do V cross U. I, J, K. Now the V vector goes first. So it's 8, 0, negative 8. So all we do is switch the second and third lines. I do the same thing. 8, 7, 0, negative 2. And then repeat the I and J columns. Find the products of these, add them together. These are all subtracted. So 0 times 8 is 0. I, negative, so it's negative 56J plus negative 16K minus negative 64J minus positive 16I minus 0K. Because minus, this becomes a plus. So we have negative 16I, 56, this becomes a negative. So this becomes a positive 8J and a negative 16K. The magnitude of that so negative 16 squared, 8 squared, negative 16 squared. It's the same thing. The same coefficient, just change the signs because we flipped them. So V cross U so it's negative 16I, 8J, 16K over 24. It's negative 2/3 I, positive 1/3 J, negative 2/3 K. So this is also 24, and it's just the negatives because we switched them. Find the length and direction of u cross v and v cross u. Could do the same thing again. Okay. Number 2. 9i plus 3j minus 8k, and the v vector is a 0. So first off, I got to find the length. So I got to find u cross v first. I, j, k, 0, 0, 0. And repeat the first 2 columns again, the I and j. Will be 0i, 0j, 0k, minus 0j, minus 0i, minus 0k. So the magnitude is going to be 0. Since it's 0, it cannot be because they have no direction. Same thing with the other one. Since the first one's 0, the second one's going to be 0. Whereas a 0 vector has no direction, has no anything. All right, number 3. Sketch the coordinate axis and then include the vectors u, v, and u cross v as vectors starting from the origin. All right. So let's look at this. Let's draw this out. I'm saying u is equal to 9i, v is negative 5j. So those are pretty self-explanatory. We just have to find u cross v. jk. This matrix is 9, 0, 0, 0, negative 5, 0. Plug in the values, repeat the first 2 columns. So 0i plus 0j plus negative 45k. Minus 0j minus 0i minus 0k. So it's negative 45k. So what does this tell us? We're looking for, on the x-axis, it's positive. On the y-axis, it's negative. On the z-axis, it's negative. Okay, so it's positive on the x-axis. So it's going to go, so it can't be that one, and it can't be that one. The y-axis is -5, so it's going backwards. And then k down, so it has to be u cross v is -45k. So it's positive on the x, negative on the y, and negative on the z. Okay, do the same thing here, this next one. Let's go ahead and draw that one out. U equals I plus K, V equals J minus K, and let's figure out what U cross V is. So U is 1, 0, 1, 0, 1, -1. No J here. So IJK, repeat the first two columns, so it's 1, 0, 0, -1, 1, -1, 1, 0, 0, 1. Remember, that's a 1. So for I, 0 times 1 is 0i plus 0j plus 1k minus -1j minus -1i minus 0k. That's a positive, that's a positive. So for the i's, we have 1i. We have 1j. And we have 1k. Make sure my cross product is correct. One, 0. Ah, that's a mistake I made. It's +1. Because it's 0, 1, -1. So that I should be a negative. Because it only affects this, which is this one. Should be a -I. Okay, let's see what these look like. So the first one says this is the I, J, K. So it's positive I, and positive k. So it's going to go up some point here. That's u. V is positive j and a negative k. So it goes somewhere down here. Now u cross v is negative, positive, it's negative I, positive j, and positive k. All right, so let's look at this. So positive and positive is u. That's the wrong direction, so that can't be A. U's going, there's no K, it says Y and K, so it's Y and Z, it's not right. This is X plus, so positive X, but so far that's right. So it's gonna have to be this one. V is positive, then negative, that's V. And then our cross product was negative I. So we go back, positive and positive. So it's C. Five. Find the area of the triangle determined by the points PQR. Find the unit vector perpendicular to the plane PQR. All right, so it's, well, be some calculations. So let's look at the sheet. So we have P, which is negative 1, 1, 0. Q, which is 0, 0, 1. And R, 0, 0, negative 1. 3 points on a triangle. Find the unit vector perpendicular to the plane PQR. So we first have to find vector U, which is going to be PQ, and vector V, which is going to be PR. So the first part is 0 minus negative 1I, 0 minus 1J, 1 minus 0K, which makes it positive I minus J plus K. Same thing with PR. 0 minus negative 1, I. 0 minus 1, J. Negative 1 minus 0, K. Makes it positive I, negative J, negative K. All right, so we have our 2. So let's find now the area is simply the magnitude of that cross product of those two vectors. Because this is the base, this is the height. So we have JK. U is 1, negative 1, 1. 1, -1, -1. It's always safe to check your numbers again, because all it takes is one sign that's off, like I just did earlier. It'll ruin your whole answer. Negative is a positive I. 1 times 1 is 1. That's a J. Minus K. Now these are going to be minus. So minus a -1, or negative J, minus a negative I, minus a negative K. So I plus I is 2I. J plus J is 2J. Negative K and K. So this is my U cross V. Now I got time to find the magnitude of it. 2 squared plus 2 squared. That's the area of a square. Since we have a triangle, this is area of a square. Base times height. We divide it by 2. So we have 2 radical 2 divided by 2. Our answer is radical 2 for our area. Okay, now what's the next part asking us? Choose the unit vector perpendicular to the plane. Unit vector perpendicular to the plane. That's going to be U cross V. Over our area. Yeah, that's the unit vector perpendicular. So it's 2I plus 2J over 2 radical 2. Factor out on top, we can factor out a 2. The 2's cancel, so we have 1 radical 2 I plus J. So that answer is going to be D. All right, next sheet. Find the area of the triangle determined by the points P, Q, R, perpendicular. Okay, so it's the same thing we just did. This is 12.4, number 6. So P is -2 to -1. -1, 0, 2. We have to find vector u, which is PQ, and then vector v, which is PR. -1 minus -2. 0 minus 2. 2 minus -1. So it's I minus 2j plus 3k. That's vector u. PR. So it's 0 minus -2i, -1 minus 2j, -2 minus 1k. 2i minus 3j minus k. So the area, since it's a triangle, it's divided by 2. The magnitude of u times. So we first have to find u cross v. One, -2, 3, 2, -3, -1. Three, first two columns. Negative is 2i, 6j, 3k. Now minus. -1, so it's -1j minus 9i minus -4k. That becomes a plus, that becomes a plus. So it becomes -7i plus 7j plus 7k. Sorry. Okay, so that's u cross v. Now I'm going to take the magnitude, u cross v, and divide by 2. That's for the area. +49 +49 +49. 147/2. Let's see what that equals. Well, let's see. Hold on. Three goes into 14 4 times with 2 left over. So it's 49. 7 times 7. So the area is 7^3/2. So that's the area. Okay, this matrix doesn't show anywhere in the 3 options. So let me check to see if I wrote anything wrong. So number 6. P is -2, 2, -1, -1, 0, 2, 0, -1, -2. So view. -1 minus 2 is +1. 0 minus 2 is -2. It's 3. So that one's correct. 0 minus 2 minus -2 is 2. -1 minus 2 is -3. It's -k. Okay. IJK 1, -2, 3. 2, -3, -1. 1, 2, -2, -2, -3. 3, -1. So that's where I messed up. Again, you have to be very careful with the signs. So that one's good. So let me do this matrix. Negative, so it makes it 2i plus 6j minus 3k minus a -1j minus a -9i minus a -4k. This becomes a plus, this becomes a plus, and that becomes a plus. So 2i plus 9i is 11i. 6j plus 1j is 7j. -3 plus 4 is +k. So it's 11, 7, 1. Okay, so that's good. Now we're going to find the magnitude. 11 squared, 7 squared, 1 squared. 121, 49, 50, 171. $171. So we know since we know a 3 goes in there, 3 goes in there 5 times. 57. 57 is 3 times 19. So this, the U cross V magnitude is 3 radical 19. For the area, it's divided by 2. That's what it should be. 3 radical 19 over 2. And so we can also use this because the vector perpendicular is to flip that one because it's 1 over this value. So the only ones that match that are these two. But the only one matches our vertex is that. So our unit vector is where's that? 11i plus 7j plus k over 3 radical 19, which means 1 over 3 radical 19 times the vector. And that we see as A. All right. Sorry about that. I went off on the wrong tangent there. Find the volume of the parallelepiped box determined by UVW. The volume of the parallelepiped is that. So what we have to do here, this is number 6. Number 7 says we have U equals 3i, V equals 3j, and W equals 3k. This is what we have here is called a triple scalar product of U, V, and W. We can use a matrix to find the determinant. U1, U2, U3, V1, V2, V3, W1, W2, W3. So we have 3, 0, 0, 0, 3, 0, 0, 0, 3. Right, so I'll repeat the first two columns. Three times three is 27, plus 0, plus 0, minus 0, minus 0, minus 0. Three times three is 27. Everything else has zeros. So the volume is 27 units cubed. Basically, just multiply those three together, since the rest of them are zeros. If they had anything else, again, it'd all wash out here. Let's look at number 8. Let U, V, and W are vectors. Which vectors, if any, are perpendicular and which ones are parallel? Okay, this one's going to be interesting because remember, we have to think about what constitutes a parallel or perpendicular vector. Question 8. This is 12.4, number 8. So U equals 5i minus j plus k. V equals negative 20i plus 4j minus 4k. W equals j minus 5k. Okay, which vectors are perpendicular? Select ones. And which ones are parallel? The way we do that is yeah, we have to find these. All right, so the first one, U cross V. Make sure the values are correct. 5, negative 1, 1, negative 24, negative 4, and then 0, 1, negative 5. Negative 1, 1, negative 24, negative 4. Negative 1, negative 4 is 4i plus 1 times negative 20 is negative 20j plus 20k minus 5 times 4 is negative 20j minus 4I minus 20K. So that's a positive. So 4I minus 4I is 0I. This becomes negative, negative, positive, 0J, 0K. U cross W. I, J, K. 5, negative 1, 1. W, 0, 1, negative 5. One, 1, negative 5. Negative, negative is positive. 5I plus 0J plus 5K. Now minus these. Minus 25J minus 1I minus 0K. So i's. 5I minus 1I is 4I. 0J plus 25J plus 5K. Now V cross W. Negative 24, negative 4. 0, 1, negative 5. Twenty, 0, 4, 1, negative 4, negative 5. These are going to be all our products. So it's negative 20I plus 0J plus negative 20K. Now minus 100J minus negative 4I minus 0K. I's, negative, negatives, and negative 24I. No, that's a negative. It's a positive. So it's a negative 16. 0J minus 100J minus 20K. So what we see here, what's the question asking again? Question number 8. Which vectors are perpendicular? Select the correct ones. We know U and V are parallel, but none of them are perpendicular. They're parallel, so there. None of them are perpendicular. One pair of pictures. The parallel vectors are U and V. All right, and number 9. See that there? Number 9. Compute I cross J and I cross J, and conclude what's associativity about the associativity products. Okay. Okay, that one. I have the formulas in a second here. So the first one we have I cross J, and I cross J. Okay, in the formula sheet I sent y'all, we talked about this also. You have these pairwise cross products. I cross J is equal to K. J cross I is negative K. J cross K is I. K cross J is negative I. K cross I is J. I cross K is negative J. Any pairs like this is equal to 0. So we have I cross J. That's the same thing as K. So K cross J is equal to negative I. Here we have J cross J is 0. Anything cross anything else, 0 is 0. So in the first one, it's negative I. And the second one is 0. So they are not associative. Because of the way the matrix is structured. Okay, number 10. Let U, V, W be the vectors defined below. Which of the following makes sense and which ones do not? That's a lot of reading in this one. Oh well. Let's look at the first one. We have U cross V dot W. The expression does not make sense because the result of U cross V is a vector, and the dot product operated cannot be performed with any two vectors. The dot product cannot be performed by any two vectors. That's wrong. That's what they're supposed to be used for. The expression makes sense because the result of U cross V is a scalar. Wrong. It's a vector. The expression makes sense because the result u cross v is a vector and the dot product operated can be performed with any two vectors. True. Does not make sense. It does make sense because it's true. So the second one, we have u cross v dot w. The expression makes sense because the result of v dot w is a scalar. True. And the cross product operations can be performed with a vector and scalar. No, that's false. The expression does not make sense because result is a scalar and cross product cannot be done with a vector and scalar. True. So far, this is the best one. The expression makes sense because it doesn't make sense because u dot v is not a vector, it's a scalar, so that's wrong. No, so the only one that makes sense is B. Remember, cross products give you vectors, dot products give you scalars. U cross v cross w. The expression does not make sense because the result of u cross v is a vector and the cross product cannot be operated. Wrong. The expression does not make sense because the result is a scalar. Wrong. The expression makes sense because the result is a scalar. No. It makes sense because it's a vector and cross product between two vectors. True. U dot v dot w. All these questions are is understanding what the difference between vectors and scalars are and the cross and dot product. The expression makes sense because the result of u dot v is a vector. No, it's a scalar. It makes sense because it's a scalar and the dot product operated can be performed with a vector and a scalar. No, it can't. You need to have two vectors. The expression does not make sense because u dot v is a vector. No, it's not. It's a scalar. The expression does not make sense because the result of u dot v is a scalar and the dot product operation cannot be performed in a vector and a scalar. True. That's it for that section. Good luck, everybody.